Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel higher tier paper from 2019, and this is paper 3. And we're on the final question of the paper, which is question 23. And if you'd like to see the others, just click the subscribe button at the bottom and you'll be able to see many more questions like this. So question 23 is quite a long question, and it involves a bearings question. So we've got 3 towns, it says here. Acton, which is A, Barston, which is B, and Chorlton, which is C. And what we've ultimately got to do is find the bearing of Chorlton from Acton. So if I was to draw a line from A to C there, then the bearing would actually be the angle from north going in a clockwise direction until we got to the line going from A to C. So it's actually this angle here. This is the bearing of A to C. So ultimately, we've got to find out what this angle is. And this question is actually in several parts. We're going to use, initially, we're going to use the cosine rule. Then we're going to have to use the sine rule. And on top of this, we're also going to use some of our knowledge of angles within a triangle as well. So we've got lines crossing parallel lines here. So these north lines we've got are parallel lines, and so they've got the rule. We've got the rules where certain angles are equal on a line crossing parallel lines. So, for example, this 37 here would be, if we was to extend the line down, if we said extend this north line, we could find this angle here. So we could say that this angle, because we've got an alternate angle to this 37, is also going to be 37. And that's actually going to be something important as well. So we've got lines crossing parallel lines as well. So we need to know the rules of those. So first of all, I'm going to try and find this angle, which is ABC. So I'm going to try and find angle ABC. And the way the notation works is the angle is actually at the middle letter here. So we've got, here's B, so it's the angle going from A to B to C. And so it's this angle, the total angle there. And one thing that we do know, if we were to draw a little sketch of the situation at the top, we've got the north line there, and then at B, we've got this line here, and also this line here, the line going from B to A. And also we could extend the north line down. So what we've got is, this is point B. We know this angle is 150. And we've also previously worked out this one is 37. So this is this one. And because we've got a straight line going from the north line and continuing down, then the angles on a straight line add up to 180. So that means that this angle here must be 30 degrees, because the 150 plus the angle here, 30, must add up to 150. So 180. So what we're saying is, angles on a straight line add to 180. And so that will allow me to find this angle here. And in fact, then if we add these together, that will tell me that we've got the angle ABC is going to equal the 37 plus the 30. So 37 plus 30. And so that's going to give me 67. So we found the angle at the top of the triangle. And what I'm going to do is, I'm just going to draw the situation again that we've got. So here we go. Here is our diagram, but just simplified without the north lines on it anymore. And so we know this angle here is 67. Put the letters in at the corners, so that's A, B, and C. We've also got these lengths here. So this is 8 and this is 9. And what I'm going to try and do is I'm going to try and find this length AC. I'm going to call this X. And to do this, we've got this situation. We've got an angle in between two lines that we know the length of. So we know the length 8 and we know the length 9. And we're trying to find the length opposite the angle here. Then what we can use is the cosine rule. And the cosine rule is based upon a standard triangle. So we may get slightly confused with some of the letters here now. There's a little bit of a conflict of letters, but standard labeling of a triangle is that if I call this one A, B, C, so I use capital letters, then the lengths opposite are written in lowercase, so that's A there because that's opposite the A, capital A. B, I'd use small lowercase b, and the one opposite the C is a lowercase c. And the cosine rule then is that A squared, so that's the length there, A squared equals B squared plus C squared. So it's looking a bit like Pythagoras, and then minus 2 times B times C, and then all times by cosine of the angle A. So that would mean the angle that was there. So what we're going to do is we're going to try and apply it to this triangle. So what I've done is I've just copied these over to a different page just so we can see things a bit more clearly. And we're going to apply the cosine rule, which I've just redrawn here, to this triangle that we've worked out from our bearings. And one of the problems that we have that can be a little bit confusing is the letters aren't always in the correct order for the cosine rule. So we have to apply this so that the A that we've got here is actually the thing that we're looking for. And so we can see that since we want to find out what X is, we want this to be our A. So I'm going to relabel this triangle so that I can then apply it to the cosine rule. So I can put everything into this correctly. So I'm just going to change the colour of the pen so we can see clearly what I'm talking about. So for that, because it's X that I'm looking for, then that's going to be my A. And so this is going to be my angle A. And then the other two sides are now going to be B and C. So labeling it, going clockwise from the A, B, C. And so that means that the length opposite the C, the angle C, is this one, which is the 9. And the length opposite the angle B is the 8. So this is our B that we're going to apply into this formula. If I substitute into here, what I've got is my A is actually X. So I can say that X squared is equal to, and then B is 9. So it's 9 squared plus, sorry, I got that wrong there, didn't I? That's going to be 8 squared is B. And then the 9 is C, so it's 9 squared. And then it's 2 times B, which is 8, and C, which is 9. And then times by cosine A, and A is our angle at A. So that's 67. And what I can actually do, if I want to find out what X is, just to make things easier and have to do less calculation, rather than working all this out separately, I could put it all in the calculator and also say that X is equal to, since we've got X squared there, to get rid of the square, I have to square root. So I could say that X is equal to the square root of all of this. So I'm just going to get my calculator up and I can put all of that into my calculator. I can find a place to put it. There we go. So square root of, and then 8 squared plus 9 squared minus 2 times 8 times 9 times cos 67. Just close that bracket. Just go equals. That should give me my answer. So what I found out then is x, or in other words, the line AC, is actually equal to 9.4199, etc. So we want to write down as many of those figures as we can in order, because we're giving our final answer to one decimal place. So we're going to round up as late as possible in the question to 9.4199. And in fact, we will be using the answer button as well, which means that we don't have to type this in again. So when I'm later in the question and I'm going to use this number, I'm actually going to use the answer button. So we've got x is 9.4199, etc. So 9.4199. I think it was 1 after that. Okay, so we're back in red. So what we're going to do next, now we know that this length is equal to what we just found, 9.4199. We actually need to find this angle here. This is the next important thing to find. And to do that, we're going to use sine rule. And what the sine rule states, again, if we've got a standard triangle, so I'm just going to draw that out. Standard triangle. We've got, so with the standard labeling, so I've just say A, B, C. Then again, the opposites are the lowercase versions. And the sine rule states that sine of angle A over A is equal to sine angle B over length B. We can apply that to this one, and this is handily actually now labelled correctly for us to substitute into this formula, because we are looking for the angle at A. We are looking for this one. I'm going to call this x again, so we know what we're looking for. And so we can say, well, sine of the angle at A, this bit, we put that into there, we can say sine x, because our angle A is actually x now, over the length A. Well, this is our length A here, because it's opposite the angle A, and that's 9, and that's equal to, so if we use this angle here, B, sine 67 over the length we found in the last part of the question, so over 9.4199, etc. Although we're going to use the answer button on the calculator anyway, so we won't need to type all those figures back in. And if we rearrange that a little bit, just to make life easier for us, we can times both sides by 9, and that's going to make it sine x as the subject. So we'd have sine x equals 9 times sine 67 over this. I'm just going to round it up at the moment as 9.4. Okay, just for writing it down, it doesn't mean I'm going to put it in as 9.4 into the calculator. So we're actually looking for x. So if we've got sine x equals that, then x itself is sine minus 1 of all of this. So it's sine minus 1 of 9 times sine 67 over the 9.41, etc. Okay, so I'm just going to get the calculator up again. And here we are. So I'll just clear that off. But remembering that we've still got this figure in the calculator, which is our length A to C. So I'll just clear that off. And I'm going to use my sine minus 1. So to do that, I've got to use shift, press sine, is sine minus 1. And I'm going to use the fraction button. It's much easier to do this rather than work everything out separately. So just putting it all in the calculator like this. So 9 times, and then it's sine of 67. Close the bracket. And I'm going to use the navigation keys, which is these ones here. Just go down into the bottom of the fraction. And I'm going to press the answer button now, because that's going to put in the previous answer that we had, which is the 9.4199, etc. And so use the navigation button to go out of the fraction, and then close the brackets. So that will give me, press the equals button now, that'll give me x perfectly accurately. So that's the angle x there. So we need to remember what that is, 61.5786. I'm just trying to remember it because as soon as I start writing, the calculator won't float on top, so we won't see it. So 61.579, if I'm just rounding it up for the moment. 61.579. So we're not quite there though yet, because we were after the bearing of C from A. So I'm just going to quickly sketch the situation. So we had a north line like that, and then there was A, and a line down to C like this. There's where B is. Okay, very roughly. So what we had, there was B, there was A, there was C, and we've just found this angle here, the 61.57, so I'll call it 61.58 actually, just round it up for the moment. And we were given this angle here at the beginning, and let's just look at what that was again. So, or we found it by using the lines crossing parallel lines. So we found that that was 37 degrees. So this one is 37 degrees. And so the bearing is actually, this being the north line, it's the angle, if we was to face north and then turn until we, so standing at A, face north and then turn until we was facing C. So that's going to be the 37 plus the 67. Just do it in a different colour. It's probably obvious what I'm trying to say at the moment, but just to make sure. So it's this angle here. That would be the bearing. So it's the, if I was facing north, I'd have to turn through the 37 and then through the 61.58 until I was facing C. So that's my bearing of C from A. So just turn back to red again. So what I've got to do is I've got to add 37 onto that. So the bearing of C from A equals 37 plus this 61.579. I'm just going to use the calculator just because I've rounded up this figure, and I'm going to use the answer button again, or use the figure that's on there. And I'm just going to add 37 to it. There we go, answer plus 37. So that's 98.58 to 2 decimal places. But we were asked to give it to 1 decimal place. So let me just write down the first 4 places there, and then we'll look at it again. So 98.5786. But we want it to 1 decimal place. So that means we're going to cut it off after the 5. So there we go. That's where we're cutting it. And what we've got to do is we've got to look at the place after the 5. And because that is a 7, so it's 5 or more, that means we add 1 onto our 5 to give us 98.6 degrees. And that is our bearing, apart from we need to add a 0 on the front because it's a 3-figure bearing. That's something I forgot to mention at the beginning. So bearings are usually as 3 figures, and we've got a decimal point after. But the 3-figure bearing there is 98 degrees, but then we add a 0 at the front as well. So 098.6 degrees is our bearing. That's it. So I hope that's been helpful to you. If it has, please like this video and also subscribe to our channel, which is Best Maths Tutors. And for more help, visit our website, which is bestmathstutors.co.uk. Thanks for watching.